So also, oh yeah, hi Hassan. We just found that Hassan also joined us. So we have very good panelists. So this panel is going to work in the following way. First, I will kindly ask each panelist to use 1 or 2 minutes to self-introduction yourself, and then I'm going to lead several questions, and I'm going to go through these questions one by one, and panelists will show their opinions, and the audience will ask questions, so we have more time for interaction. Okay, now let's get started. So maybe I will start from Jason. Yeah.
Sure. Hi, everybody. So I am Jason Low-Power. I'm an assistant professor at University of California, Davis. So I guess if you're here for my talk this morning, I talked a lot about ways we can use software to better manage data movement in these heterogeneous memory systems. Beyond that, we're also working on hardware managed data movement. So through things like DRAM caches, as well as I've done a lot of work on cache coherence in the past as well. And then the other thing that we technically talk about analysts, we were talking about moments ago before the panel started was modeling. So I run the HCM'23 simulator. And so thinking about how to model CXL is something we've been doing a lot lately as well. So thank you for having me.
Hi, I'm Daniel from Microsoft. As you see, I presented kind of from a very production and practical point of view, but I'm also super interested in learning from you guys and trying out all kinds of new fancy ideas to improve. Basically, how much CXL we can use at a given performance. Do you want to use much more CXL and get really good performance? Basically, high latency. Basically the same as Jason.
Hi, I'm Manoj Wadekar from Meta. And as Daniel said, of course, I think we are all interested in figuring out how to do this memory. Use this CXL-based memory. Memory is a significant part of the BOM cost in the data centers today. It's something that we definitely want to see how it is solved as CPU and networks and everything keeps on growing. We want to make sure that memory can keep up the growth. This is where we are working with OCP also, it's composable memory system, and therefore that all of us work at. And I think it's kind of a beginning, and there are a lot of use cases where we see, especially in the AI/ML space, that memory segregation or memory expansion is going to be key. And a lot of those things are not defined yet today. We are in early phases, so we definitely look forward to what all ideas people are bringing forward so that we can take it to the actual production at some point of time. Thanks.
So, hello everyone, my name is Michele Gazzetti. I'm a research software engineer in IBM. And my journey with composable memory started 4 years ago when we built a research prototype called the Timesys Flow based on a coherent interconnect OpenCAPI that now is an asset under the XI consortium. And as part of this project, I was in charge of the software support for the management of disaggregated memory. From this project, we actually realized the potential of disaggregated memory, but also the possible gap that we could have from a management perspective. That's why we joined the Open Fabrics Management Framework Working Group, where we are trying to define the data abstraction for representing composable or network attached resources for easy consumption and management inside the data center.
Okay, I'm gonna ask the remote presenter to give the self-introduction. Devendra, you want to start it first?
Sure. My name is Devendra Das Sarma. I work for Intel.
Hear you.
If 1 minute. Cannot hear me. Can you hear me now?
Here we go. We have you now. Yeah.
Okay. All right. So my name is Devendra Das Sarma. I work for Intel, and I led the initial CXL consortium, and I'm still involved with the Compute Express Link. So problems that CXL has been trying to solve, and very thankful that the entire industry has come together, is the notion of solving initially the memory bandwidth problem, right? And the memory capacity problem, the cost problem through direct attach. And eventually from there with CXL 2.0, we moved to the disaggregation of memory across multiple servers. And with CXL 3.0, we took it even another step forward to build really truly composable systems of, you got servers, you got accelerators, you got storage that you can do mix and match. And not only that, we enable with CXL3 the capability for these to work in a collaborative manner through shared memory. So it's the entire gamut that we covered through CXL. Now there is another one that we're not going to talk about today, but I want you to pay close attention to that, and that's the what's happening on the package, right? And clearly with all of these memory moving, whether it is from on package to DDR attached memory, for example, to CXL attached memory, to once you go to a pool of memory, your latency characteristics are very different, and you need to make sure that you are using that memory efficiently. So with UCIe, we have defined the magnitude of, and we'll talk about UCI there is another session today. We'll talk about that in a lot of detail, but you fundamentally get a huge amount of bandwidth density and much lower latency, right? So what does that open up in terms of opportunities, right? And this is the continuum that we all need to work through in order to do this, heterogeneous and composable memory. And by the way, with CXL, what we have been able to do is earlier your memory in the DRAM, DDR buses were all the same type of memory. If you implemented DDR5 6400, all your DIMMs had to be DDR5 6400. With CXL, that assumption is no longer necessarily true, right? When you can make them, but it's not required. So very exciting time, and the journey continues. And definitely, like Daniel, I'm here to see what usage models you guys have and where can we take this technology going forward.
Okay, thank you. Hassan, you want to?
Yeah, so I'm a final year PhD student at the University of Michigan. So my PhD is mostly on like how to make memory disaggregation practical, to address all the practicality challenges of memory disaggregation. It could be like hiding the latency, how to make it fault tolerant, how to make it more efficient, like less data movement over the network, and like how to make it for public clouds, and even with newer CXL systems or newer tiered memory systems, how we actually going to manage page placement and do all the challenges to make it more adaptable, more accessible in deployable to existing data center. And we mostly focus on developing application transparent tools so that both new generations and earlier generations solutions can easily access or easily use memory disaggregation in today's data centers. And as there's lots of challenges and technologies are mostly moving pretty much faster, and we feel like memory is becoming almost similar to the network. We feel like there's a lots of new challenges, like let's say QS can be another stuff for memory. And when multiple applications or multiple types of applications run together on a rack scale server, how we are going to provide quality of services when they actually interact with each other, and how we actually go to share the bandwidth, or how to provide the service level agreement between different applications when they share both same types of devices or run on the rack scale. So all of the different practical challenges of memory disaggregation is basically what we do in our lab. And in my PhD, we develop lots of open source solutions to address each of these aspects. Some of them actually get one of them actually is already been used in Meta, like the TPP, and it's been already been merged to Linux. So it's most of the software-based solutions for making memory disaggregation practical, and that's it.
Okay, perfect. I'm going to perfect. Next, I'm going to go through the question list. The first question I'm going to ask the panel is that, nowadays we have seen many solutions regarding the memory disaggregation, and those solutions could be server local memory capacity and bandwidth expansion, and could be small scale memory pooling without without the hardware cache coherence, and it could be large scale and multi-layer switching. So you see we have these stages, different stages, the deployment of this HCM solution in different stages. And the question is, in your view, when do you expect those deployment stages to happen? And we see some academia papers already there, but in production, we just start to see they happen, right? But it's still not clear when those different stages is going to happen. Can you share your opinion about that?
Sure. You want to talk to me?
Yeah, as you could see in my slides, we've been very, very hard thinking about that question, including all the way down to designing new blades, new racks for all of these purposes. Right now, if we can tell, the first step is very close. I would say that's on the order of a year or two, I think. For pooling, things are much harder than we thought, I think, actually, like building a rack that really supports that. And I would love to hear what everyone else thinks, but that we expected that to happen soon, but I think that's further out in reality. And because even a small scale pool is hard, I think large scale pools are going to be even harder. Like when we think about what we said earlier, CXL as a big fabric, as a network, I think that's at least 5 years, probably longer out in really reaching production. That also means, though, from a research perspective, you can still really actively do research and influence this. You know, we are at the perfect stage for you to be involved.
Yeah, let me maybe take a little bit of a step back and just look at what the use cases are going to drive. But maybe you can answer the question, kind of say that, you know, some of the deployments will start soon, as Daniel said, but it depends on the use cases, because for us, looks like, you know, and what Daniel is pointing to is the important thing. For data center wide adoption, the cost and power is very important. So the use cases that can actually provide the right benefits are the ones which will get prioritized. We know that actually the amount of memory that we put on the boards is pretty high, which basically drives the cost, and it's going to get higher because processing power is going up. That means you will need more memory. So when you look at use cases or applications like caching, data warehouse, or virtualized servers, all of these basically that require higher amount of memory are going to need good solutions. So the CXL, I think one key thing that it enables is really heterogeneity. So you can mix and match. Like Daniel talked today morning was, you can have a DDR5 as your near memory, and you can have DDR4 as your remote memory. There could be memory technology that will come down the pipe. So all the work that is being discussed right now is very important for us to have a viable roadmap. But DDR5 and DDR4 can be a very good starting point. So some of these use cases that we see are definitely a good starting point that will happen for native memory expansion for us for sure. The pooled, of course, has its own time and place and the challenges that Daniel is working hard on that. And we see the point of it also, because at some point of time, we are going to start running out of real estate on the board. And at that point of time, we have to go and start pooling them. Sharing will be even larger problem after that. There is a second area that we see where there is a potential for even earlier adoption is basically AI/ML space. There, the memory footprint is even larger because the amount of processing you can have on accelerators or GPUs, multiply that with the embedding table sizes that you will per node. The amount of memory that you need to put on a node goes beyond what the platform can support, because you run out of memory channels multiplied by max amount of memory that you can have. So this is where I think, again, it's very much possible for us to have more optimal platforms for inference kind of platform, for example. Training is the next step problem also. But I think these two use cases, native expansion and inference kind of platforms, are the two areas where we see very soon solutions coming out. Now, when actually depends on multiple components, and this is where hardware software co-design comes into picture. Hardware side, you are just beginning to look at the process of that are supporting CXL. So CXL being the fabric here. There's a lot of software work that also needs to go on be shared. Hassan has talked about TPP. That's a work intro, and it's already in the open source. There's a bunch of activity that needs to happen. There are multiple standard bodies that are working together. So for practical adoption, all these standard bodies, all these open source solutions have to come together at a system level. And I think that's a journey. I think it's very soon, but it's going to be a journey.
Yeah, I tend to agree. I can provide like maybe a different reading. It depends also on the scale of deployment that we are talking about. If the deployment size becomes smaller in case, for instance, of private cloud installation or this kind of data center, they probably have depending on the availability of the hardware, better chances of actually going and test this solution earlier, mostly because of difference in an initial investment. And in terms of when the different deployment will be available, there are already like some companies that are trying, for instance, to provide switching, but with CXL 1.1. If they are deployment ready, is I think is still an open question. But we see that there is some interest in going fast.
From the academic point of view, I can't say anything to this. Although I do think it's really interesting that, I look at this deployment and I see it as much further out than something like a year, because there's no way for us academics to get our hands on any of this hardware. Like that isn't even on my horizon in any way of us getting our hands on the hardware that we can start playing with. So I think that that's, looking towards the industry people here. If you want academics to be able to start pushing some of this research forward, I think we need some kind of platforms to start doing research on, either simulation-based, like we'll talk about in a minute, or some pre-production hardware or something that we can start playing with.
Great. Any comments from the remote panelists?
Sure, I'd like to chime in. So, for the academic point of view and the availability of platforms, we had provided pre-production hardware support to those that had asked us. So, but then the good news is Sapphire Rapids based systems are available. So, and those have CXL, the first generation of CXL. So, you can get your hands on those. Now, that aside, coming back to the topic here, which is, which of these that I see being deployed, it's like, others have talked about, it's going to be a crawl, walk, run, right? And we are in the crawl phase right now. Fundamentally, there are two sets of things that need to happen. Right? There is the tiering aspects that people talked about. Clearly, that needs to happen because memory that is farther away will have higher latencies. People will figure out ways in which to place data, the hotter data closer to where it needs to be consumed so that, your latency impact is minimized. But on the other hand, I also tend to think that if you look into the memory bandwidth problem, we just cannot add more DDR channels to solve the memory problem, okay? We are fast running out of options there. I mean, how many more channels can you add? Every DDR channel is 300 pins, okay? And you get what, 50 gigabytes per second of bandwidth, somewhere in that range, right? Or maybe a little bit more depending on how fast you run the thing, right? Contrast that with CXL based, let's say a CXL3 based kind of memory that you will attach. So there, if it is a by 16, it's 64 pins. And the amount of bandwidth that you get is 256 gigabytes per second. So, it's just an order of magnitude better, right? Now, on the downside, of course, we got latency is higher. It's like a one hop away kind of latency. But the good news there is that with a lot of good hardware engineering design techniques, that number can be significantly minimized. And a lot of people are really working on that, right? So fundamentally, the initial implementations that you see coming out of the industry is got higher latency because people are very used to PCI Express based kind of design. So, 10 nanoseconds here or 5 nanoseconds there doesn't matter, right? But those of us that have been designing, for example, CPUs, cache coherent links, we will go and fight for every half a nanosecond, right? Sub nanosecond, we will go and fight like our life depends on it, right? The industry will gradually move towards that side. You will still have a delta. And there is no way you can contrast. Well, I shouldn't say no way, but I just don't see, right, an obvious way to compare a parallel interface with a SerDes-based interface, which is CXL. But then the number doesn't need to be as big. It can be substantially lower, and then our applications just need to evolve so that we are not using it just as a capacity tier and having tiering approach, but also we are using it as a bandwidth tier, right? And then the rest of them will actually follow because, once you, and like Daniel was saying, right, I mean, the even small scale pooling, I mean, once you solve problems with small scale pooling, of course, you're going to get unique set of challenges with large scale pooling, quality of service, all of those, how do you enforce becomes a challenge. But those are all going to be solved, and it's going to be a learning curve. And again, this is what we have done in the industry, right? If you look at PCI Express, you start deploying, and subsequent generations you keep improving. And right now, what you have there in that ecosystem, where also I come from, 2 decades later, it's going really, really, really strong. So this is an excellent start to the journey. The key thing here is that all the major industry players, right? Pretty much, I cannot think of anybody that is just not there, right? So this has to succeed. There is no other way. And it has to succeed spectacularly.
Okay. Okay, great. Hassan, any comments?
Yeah, I agree with all of the most of the speakers. I think we can move to next one.
Okay. Okay, great. I'm gonna go on to the next question. The next question is in order to use HCM, do you expect to change applications or create new programming models? If yes, how? I think our keynote give some comments about that, right? I mean, there's also some recent work introducing new data structures and application levels so that we can design the page migration better, data object migration better. I would like to hear more comments from panel. What do you think of this question?
Sure. I can start with this. Of course, there are main things that drives us for adoption. This is where the challenge. How do you see it soon, and how do you make it with less change, right? So I think for CXL adoption, for us at least, we see that the less changes to the applications allows us to make adoption much faster. This is where, as long as applications don't need to be changed, we can adopt it better. So anything that allows us that translation, whether it's in a kernel or whatever it is, that actually is the benefit of it. Now, there are a few applications which believe that actually they have much better knowledge of memory accesses, memory patterns, and they can manage the near and far pool memories, near and far memories much effectively. So that work, I think, we will continue. But I think early adoption perspective without changes is going to be better. But there are going to be, in AI/ML space, perhaps the models are much more evolving, you have more flexibility, and this is where perhaps there is a potential for managing it much better. But most of the CPU side applications they're adopting, then I think that I would say that actually it's one model that will be always there, but at least it will start with which requires applications to not make change.
As the one who keeps pushing for nothing can change because we're a public cloud, I do want to actually second Manoj's opinion. We will see all models. We will see hardware support. We will have software migration. We will have what we do, like very naive things behind the scenes at the platform level. And we will see applications adapt. I can tell you inside Microsoft, all the major applications that have at least 5-10% share of all the resources of learning. Number one, that is database systems. That's the biggest application in the cloud. all of them are adapting. All of them are actively working to do this. But as Manoj says, it'll take time. This is a really hard problem. So one application problem we see a lot is that it's really hard to know what's hot, right? So you need some hardware support to track hotness and inform you, but then what's the API? Then you have to change hardware. It's a long pole to really make things away. But yeah, all of them will happen, all of the different models.
Also, application that, for instance, schedule workload and take care of the management of workload will need to change to support this new level, this expansion in the space of possible configuration that we could have, right? Because scale out is not the only option anymore. Scaling up becomes an option. So it becomes tricky to understand what we need to do smart placement and if we need, for instance, help from the hardware to actually have more knowledge and take the right choice.
I want to actually say just one thing about that. So when we place a VM, it's about a 10-dimensional problem because that's how many resources we manage and track between memory bandwidth and network bandwidth and CPU cores and whatnot. CXL will be the 11th dimension in that problem. So working on scheduling algorithms has become more interesting, I think.
And so I'll just echo what I was talking about in my talk this morning, which is, I don't think that we can expect programmers to be able to understand how to move their data around or where to put their data and when to move it. But I do think that we can expect the programs to be able to do it. And I think that we have to use the semantic information from the program in order to do this efficiently. We can't just have these blind systems like the operating system or hardware doing all the data movement for us. I think we really need that semantic information to come all the way from the application level down into the mechanisms that are moving the data around.
Just quick follow-up, and I'm sorry, but I think what you brought by a very important point also, the scale up and scale out, because the models have evolved a lot more towards scale out in recent generation. And I think as we start have a potential for having hierarchy of memory inside a node, how do you really scale up? And not only for compute-oriented applications, but also the accelerator GPU-oriented applications, especially in the training workloads. I think this is an area definitely that requires perhaps a lot of work and from this community efforts, at least for sure.
Okay, any comments from remote?
Yes, so from my perspective, it's like if you want an early adoption, you need to like make it application transparent, because you cannot bring up a new solutions or new technology and ask everyone to change their applications overnight and use that. So for the very beginning of early usage, you should give some solutions that is transparent to the application so that current applications can enjoy the same systems. And when things will get more common or people will want to use more advantage of these hardware systems, then maybe new programming models will be helpful for them to use these types of system more easily or more optimized way. So I feel like research-wise or academic-wise, new programming model will be available on how optimizedly you can use these things. But for now, when you have to like make it more easily deployable or easily adaptable, you should obviously give some transparent solutions for applications.
Okay, great. Any comments from Anna?
Yeah, I think pretty much others have covered the different aspects here. I think it will be all of those above. And like Hassan said, the best solutions are it works just out of the box, right? With no changes to the existing applications and things like that. So it's going to evolve. All of it is going to come up together. So one example, for example, of an application specific one would be, you got what we call an app direct memory, right? Your application needs a huge amount of memory. It can deal with, these are again very specific applications. It can deal with different latencies and it can give the right hints in order to manage the latencies. And I don't know whether it was, I think it was Daniel who mentioned, right, that we need some also some help from the hardware side to identify which are the hot pages, which are the cold pages, and we are working on those kind of things. So all of these things will be coming together to make it more and more useful, right, for the vast majority of the folks, right? The good news is that the hardware is already out there. People are already experimenting with it, and fine tuning will happen to enable all of those different types of usages going forward.
Okay, great. Actually, I'm looking at the time now. I don't want to have later lunch. So I still have 3 questions, but I'm going to stay with them. Instead, I'm going to open the floor and ask the audience to ask a question to the panel, because that's supposed to be the fun part of this panel discussion. So, any question from the audience? Any questions open? Any questions? We only have one.
Yeah. I'm from the design automation community, and I wonder whether companies like Microsoft or Meta build your own customized hardware like PCB and chassis for your systems, or you will outsource it to companies like Intel and Broadcom or HP and Dell. And how much does it cost to design many heterogeneous hardware?
So of course I can give
I
the
take
number, but I can tell you.
I think I understood the question. Can I?
So for scale, it's a good question. I mean, one of the questions that I think that was there was, what are the major challenges? So one of the major challenges that has to be addressed is basically how are you doing with cost and how are you doing with power? So the system that we build have to have the right cost improvement, because CXL is adding a component in a system. So that memory cannot be more expensive than the solution that we have. So Daniel talked about the efficiency by reducing the stranding. Similarly, what we can say is basically how do we really improve the overall utilization of the server? So that's how it's save the cost. So the hardware that we, of course, we would work with a lot of times tends to be maybe first generation or experimental to start with, because we see the pain point a little bit earlier, I guess, because we have been using it and we know that it's a significant part of our spend. So you will see that the reason we talk about when it will come out is because we do see those components coming in, systems that we can start deploying in our fleet so that we can get some early data so that we can go to production. And Meta always puts out, and Microsoft also always puts out our hardware in the open community through OCP. So you will start seeing those components coming to open community soon. But I think the challenge for the industry is going to make sure that we can continue to drive it, very much focus on how do we continue to drive the efficient solution from cost perspective, power perspective, and provide the right accelerations. The discussion that happened, like, the challenge for us to more efficiently utilize memory is going to be, do we have the right use of the tiers? What is hot and what is not hot? So getting that in the right information from the right components without really compromising the maintenance of cost and power. That's going to be the key goal. So even though I can give you exact numbers, but yes, we do work with the industry standard solution. Industry standard solutions are good for us because that drives the whole economies of scale. So we work with everybody, and that's what we continue to do.
Yeah, I want to just reinforce. Work with Open Compute, look at Open Compute. We publish our specs, and yes, we customize.
May I ask a follow-up? So, if you share or amortize the run cost across different companies, how could you find out the common components to be shared across different requirements and different applications? Sure.
We talk to each other. We have a working group in Open Compute on composable memory systems. So we work together, we present our requirements, our problems. Yeah, we work together.
And
I think
so
if I can add to that,
plug in there for OCP, there's a weekly call, and anybody is open to join and feel free to. One thing I can say is that there are many standards bodies that work on it together. Well, they work on it, so we are making sure that they work together on it. you will see that actually CXL consortium is working on standardizing what controllers should be providing. JDEC would work on what memory modules are going to be, what standards they provide. SNIA is working on some of the expansion boards. Post you'll see hardware contribution coming up for the full board design and expansion boards and the memory shelves. So our goal is to basically make sure that we continue to drive the open ecosystem, because that's the only way we can really enable the market, and that's actually purely selfish perspective is good for us.
By the way, would you like to share something with the academia instead of only inside the industry company?
So the question, let me rephrase. The question is, how can you share this hardware resources with academia?
I see. It's a good question. I mean, all of us work directly with the academia. There is not quite clear whether there is a common resource pool. We started this Homogeneous Memory System group started with the future technology initiatives, which is actually really working with the academia. But I see what your question is basically, how do you make the hardware resources available? So there are two aspects. One is basically we can continue to share what our pain points are and what our workload profiles are and what our benchmarks and what our metrics are for us when we adopt things. I think the hardware sharing is something that I think we'll have to figure out and work individually many times, because typically each company works directly and there's no common place where we can do that. But I think that's a good question if that's the part. But out of these three, it's basically sharing pain points, sharing the patterns and profiles and benchmarks. And the third one is hardware. I think third one, perhaps we have no global solution, but maybe more point solutions. Okay. And I know research organization like IBM continues to work with the academia also.
Yeah, exactly. So for instance, TPS Explore is open source. It's based on load store semantic, and you can go check it out. It's an open reference design. So it could be used, for instance, install on FPGA and see how memory disaggregation can work. It's not CXL. So probably an open reference design for CXL will probably help as a platform for the academia to test some new ideas and bring the feedback also to the community and help everyone in the process.
Let me add quickly one more thing. Hassan's work, which is transparent page placement, is already accessible. So that's something that you can definitely take a look at for us to work on. Second part is basically our largest use case for large memory systems, which is caching. So the cache lib is also open source. Cache bench, which is the benchmark and metrics, is also open source. So if you have innovations that you want to really demonstrate the value of it, all of these are open source contributions, which actually go directly to compare how it would work on the Meta's fleet and how it would look, because we published the profile also along with the benchmark.
Thank you.
Any comments from remote?
Yeah, if I can. So I think the question was around, hardware, availability, right? And does this really require special purpose hardware on the board? And the answer to that is, other than the disaggregation kind of part, the beauty of CXL is that you are using a PCI Express infrastructure. So you can use the PCI Express form factor. So imagine that, you get a CXL based device from a third party. EDSFF is going to be the most likely one people will use. You can just plug it in an existing system and then do whatever experiments you want to do, right? And people talked about open source software to help with all of that. So those are all great things, but something to keep in mind that you don't need to build a special hardware board to do your CXL work, right? And of course, if you want to, and I know that OCP has things where you can put multiple sorts, let's say CPUs, multiple memory boards, and do your pooling work. So that's also available. But in the direct connect kind of model, it's pure plug and play.
Yeah, and I feel like accessing the hardware is very fine, but as if those hardware is not available, you can always emulate the environment. Like you can configure a multi-socket system, let's say 2-socket or 4-socket systems, to behave the same as it could not be the exact CXL system, but you can build something emulating the CXL environment on multi-circle systems, and then when real systems will be available, they can be easily portable there, because the beauty of CXL is like the devices appears to the OS as a new NUMA node. So whatever you can work on these multi-NUMA node systems could be like easily portable when the hardware is available there. So.
Any other question from audience? Yes.
I'm Steve from Richardson. Just want to continue with a comment on sharing the hardware resource. I think it will be really helpful if there could be some sort of open source CXL external CXL controller code that academics can use, and then you get actually a prototype of new hardware memory controller features. So something like what RISC-V folks have done. They have the Open Python, they have the Berkeley Open RISC-V course. Academics can essentially get a framework and then just implement the new feature that they want to demonstrate in their new research. I think that would be really useful. We can get out of the simulation shop that more and more is just for students to get attract students. It's become harder and harder to just say, I'm going to do a simulation. So that's a comment there. And I have another question about this, essentially with CXL memory becoming more and more mature. Bandwidth is already faster than the DDR, or local DDR, and then latency potentially improved in the future. And I'm just thinking 5 years down the road, maybe long term, what is the responsibility of local memory, or is there a need for local memory, or will local memory just be like a and totally replaced by CXL? I'm just trying to get a sense of the future landscape.
I wanted to just also answer to the first question. So it's not something we do, but I've heard from other vendors that an open source FPGA CXL is actually in the works by a major vendor. It's about, I think it's going to be next year. So maybe next time when we meet, unfortunately. But yeah, people are working on that.
Second part, there was also a question.
What's the second?
Can we get rid of local memory?
Oh yeah, can we get? I think that's an open question. It's a really good question. It has still lower latency and be extremely low, like latency sensitive. So you would have to replace it with something that is also low latency, right? It could be on-chip memory. It could be, I mean, there's a lot of options, but I really don't know the answer.
I can just say there is a challenge here for quantifying local memory. Because even though we say that bandwidth is high, it depends on how much you need to put behind it also. So most of the time, if you say today 32 gig is a sweet spot of 10, that's what sits on that channel. But if I want to put it behind CXL, we have to amortize the cost and power that CXL has, which basically means we need to put more capacity behind it. So if you think of it as a bandwidth per gigabyte, actually CXL will have, CXL will have to balance that thing. Do I provide high bandwidth or do I provide the cost-effective solution? And this is why I think there is a cost point at which we can make it much more effective on CXL to add more memory behind it, but that does trade off bandwidth. So I don't know when, but I don't think local memory is going away anywhere. So in anything that I can think of.
Yeah, I think that it's still an open question. Probably it's not going to be go away anytime soon. The actually interesting question is how much local memory you need, and how much you can work with CXL, considering that the latency space is a range that we have from 150 nanosecond up to 1 microsecond, right? So this space needs to be explored, especially from the application perspective. What is the impact at different latencies? Can we sustain lower latency and still be fine for in respect to the quality of service that we need. It's always like a trade-off, right? And more performance might not be always necessary depending on the workload. So still open. It's a great space to explore.
So follow-up. My understanding that with the fastest CXL controllers, it's only about 20-49 seconds of overhead.
That would be great.
or is that too futuristic right now?
If you go to CXL, you consider around 100 to 120 nanosecond total that you will see that.
Right. I like what the overhead adds. Is it just like 20, 40 or still?
I think we're still pretty far away from that. I would love to see that.
Yeah. I was just going to comment on the local memory thing. I think, the way I kind of see it from the kind of research that we've been doing is there will probably be local memory, but it's an interesting question as to what that local memory is going to look like. I think it's totally foreseeable that DDR5, we're not going to have much DDR5 locally in the future. It might be replaced with something like HBM or RL DRAM or something else, but probably not something like DDR6 might not be. Well, we might not have 8 channels of DDR6 sitting next to the CPU. Might be something else.
Okay, any comments from remote?
Sure. I think it's always hard to predict the future, but I think there will be more and more reliance on the CXL memory. Latencies have to go down, right? And I can see that there is a lot of room for improvement in terms of what's out there. Okay, it's just going to be pure engineering. People talked about, and I had talked about earlier about, just cannot add DDR channels to work our way out of this, memory bandwidth challenge, right? So it has to come from CXL. And I think, so it will be probably a combination of unpackaged memory with, some amount of, with the CXL memory. And then I think, the point is being valid, right? Anytime you replace your memory controller that is inside the CPU, and you're connecting directly to DRAM, and you're replacing with the memory controller of the CPU, you're serializing, deserializing data. There is a latency penalty, there is a cost penalty, there is all of that, but those can be overcome by proper engineering practices. And it's not that we do not know those engineering practices, we know about them, right? So for example, what if you replace the memory on the other side with LPDDR? You're going to get some amount of power advantages, right? People will come up with these kind of different permutations and combinations and adopt the solution that works really well for them. And what CXL enables you to do is to provide you with a technology independent solution, right? So you can do these kind of different hierarchical topologies of memory on the other side of CXL and amortize those cost and power overhead, and at the same time provide the performance that you need. But a lot of things will be coming together, and this is where again, hardware is being available. People will be, and people are testing, right? I mean, there are a couple of people did talk about how their experiences in testing with CXL. So more of these will continue, and things will getting fine grained. They're going to get fine tuned, and we'll keep moving the technology so that more and more memory really goes to CXL. And by the way, Manoj mentioned about the accelerator. So for example, they have got a higher latency tolerance. So you can imagine coming through the CXL link and attaching and getting access to a large amount of memory in the memory pool from the accelerator. We provide those provisions in CXL'23, for example. So.
Hassan, you have any comments? Hassan, you mute yourself.
Yeah, so I agree with the panel. So I think everything is kind of set up.
Okay, great. So we are almost 5:20. We probably have 3 minutes for one more question, because this is going to be the last question.
Thanks for this really very
here. And so I want to actually kind of know that now there's a lot of resource disaggregation going on, especially with heterogeneous composable memory. How relevant do you think is going to be this heterogeneous networks within the data center that kind of connect and pool these memories? That's the first part of my question. And secondly, going forward in future, like maybe probably 5 years down the lane, do you think there could be a memory as service going to be offered in the data centers?
Okay. First of all, I come from storage background, so I can tell you from my personal experience, disaggregation is not easy. So we work in storage disaggregation for a long time. It does happen, but it takes work. And memory disaggregation, especially because memory is always considered to be native by CPU for most of the applications. So it's not in the DNA. So it's going to require a change. And I would love to see this exact change, first of all. But going forward to another question, basically, what would it impact on the disaggregation from the heterogeneous network perspective? This is where I think there is a potential for memory fabric to evolve. It's not there right now. Memory fabric today is basically Ethernet or InfiniBand, right? That's a memory fabric with RDMA. And of course, Mikhail will talk a lot more about it than me, but I think this is where we have an opportunity for right scale-up models to evolve, where memory fabrics can become reality and where accelerators can join into this collaborative problem solving with the cache coherent memory accesses. But again, I'm looking into the future here. I don't have any idea what I'm talking about.
So the first question was about the network.
Heterogeneous networks.
Right. When you talk about heterogeneous network, are you talking about like a fabric connecting heterogeneous resources or different networks working together?
The first one, connecting different heterogeneous resources. Like for example, you have like close on-chip interconnect, and then there are silicon photonics surrounding that, and then layers of network that can enable you.
So I think the fabric becomes, I'm trying to keep it in terms of what I know. The fabric becomes really interesting in the moment that resources are very pricey. Like for instance, GPUs. Okay, so being able to access and connect those kind of resources, even if I'm paying a penalty in terms of performance, might be useful because, for instance, a simple example, I might want 4 GPUs for my training my workload, right? If my deployment is 2 nodes, 2 GPUs, then I cannot run the workload the way I want. Instead, if we manage to disaggregate via fabric, we could try to cater for this kind of requirement. What is the price, and is it still better going scale out? I think this is an interesting question that should be explored.
Hello, can you hear me?
Yeah.
Can you make any comment?
Yes. Can you guys hear me?
Yes, yes.
Okay. I'm getting an echo. So there are different aspects here. So the disaggregation aspect that we talked about here, right? I think the question about having, just like the memory pooling, you can have the pool of accelerators even with CXL 2.0, right? You put a CXL switch, you have a bunch of servers on this side, you got a bunch of accelerators. That's a very easy model where you can the example was, hey, I got 3 accelerators, I need a 4th one. Well, you can go to the pool and get your 4th accelerator, right? That's supported in CXL 2.0. I think there was another aspect of the question, which was, hey, can I go from on-chip to off-chip using optical and build like a large composable system? And there is in the high chips talk setup discussions that we'll have later today, we'll talk about how we are defining something on UCIe called a UCIe retimer that can basically take CXL protocol over optical and help you solve with the reach problem there, right? The challenge with optical is, of course, the cost part of it, right? But again, it's not if, it is just a question of when that problem gets solved, we are going to have this large scale thing. But hopefully by then we have figured out how to scale these load store coherent memory-based interconnects into larger systems so that we can realize the benefits of that at that time.
I feel like you can build any heterogeneous system, like theoretically it's possible, but whether your application does not have this necessity, or like if you can, if it runs perfectly on your existing systems, or if does not need that kind of heterogeneity, why would you build such a like gigantic systems? Or what's the benefit monetarily, or why the data centers would use that thing? So that could be one reason whether it is benefiting in some way or not. And in terms of memory as a service, I'm not sure whether public cloud server systems will provide that thing or not, but I feel there's a lots of hot, cold portion of memory within an applications, whether this is exposable to the end user or not. But in data center, people should have some mechanism for utilizing cold memory or putting cold memory into the like further tiers of the memory or further tiers of the memory subsystems. So those can be used internally, but whether those will be like used commercially or not, maybe that depends on like cloud business and how they're thinking about that.
Okay, great. With that, I'm going to stop here because we are running out of time. And I would like to thank to panelists again, and thank you. And that's the end of this workshop. And I would like to thank you so much for your participation. And if you have any questions, please feel free to send us emails, and I highly welcome any feedback. And thank you. I will see you again next year.